I can use trigonometric ratios to solve word problems. So today we're going to take it to the last level. Let's go ahead and start with what we always like to, which is with SOHCAHTOA at the top of our page. Let's talk about two words, elevation and depression. So what might elevation mean? Maybe take a guess. Same thing with depression. So elevation, you can think of as the height, like how high something is. Or sometimes you can think of it as going up, like an elevator. Whereas depression is like a depth. If you depress something, like a key on your keyboard, you're pushing it down. So it could be going down. So if we come to angle of elevation, and take a look at what we're talking about. Imagine some ground, and imagine a plane taking off. Okay, here's my outstanding plane. Okay, and the plane is taking off at an angle of elevation because it's going up, it's elevating. Let's say it's like 22 degrees. So the ground and the plane, they make a 22-degree angle together. That's the elevating from the ground, okay? And, well, where's the triangle, you might ask? Well, if you drop down a line or a measuring tape, if you hit freeze and drop it down from where the plane is, that's 90 degrees because we measure height perpendicular to the ground. And that right there would be how high the plane is. So there's your three sides. Now, an angle of depression is a little different. Imagine we have a little tower right here. Imagine you're hanging out on top. And imagine right now you're a lookout. You're just looking straight out there, okay? But all of a sudden you see like a fire over here. So you're going to take your view, this is you looking straight out, and now you're going to drop your view down. So now your view is down, focused on that fire. So you depressed, or you went down with your view, let's say 25 degrees. So you went, and that's the hardest part. The idea that depression, you have to be looking straight out and then drop it down. Just if you remember going down for depression, you have to start up here so you can go down. Whereas if you're remembering going up for elevating, you have to start at the bottom and go up. And that should help you locate the angle of elevation and the angle of depression. So let's go ahead and do a problem with these ideas. And once you build a picture, it's just like all the previous problems we did. So the first step is to read the problem. A plane takes off at a 22-degree angle of elevation. Now I don't see a picture, so we better sketch one. And we'll just use what we did before. Okay? Here's our plane. And it's rising up, taking off at a 22-degree angle. And if we drop a tape measure down, there we go, that's going to be its height. So we did the 22-degree angle of elevation, so I can check that off. How high is the plane? So that's my find. How high is the plane after it travels a horizontal distance of 3 miles? Well, how high is going to be this right here? You can call it h for height if you like, or we can just call it x. Now, what's a horizontal distance of 3 miles? That would be this right here. Horizontal, like the horizon, is the straight line where the sky meets the earth. So this distance was 3 miles right here. So we're done labeling everything, and the question is, which trig ratio do we want so we can build our equation and solve for x, the height of the plane. And you probably have a good idea already, but we're going to use everything we always have done. Here's our reference angle. Notice it's the same reference angle here in our table of info. They gave us this side, we want that side. We're not using this one. So what are these two compared to the 22? Well, this is the adjacent. And this one over here happens to be, you guessed it, the opposite. So what's opposite and adjacent? If I go up here, opposite and adjacent is tangent. So I'm going to come back down here and I'm going to write out my equation. The tangent of 22 degrees is equal to the opposite, x, over the adjacent, 3. So what is the tangent of 22? Well, according to our table, every similar triangle, it's always 40 over 100, or 40 hundredths. And so you could reduce first, but it doesn't really matter. I'd like to divide by 100. I'm going to get 100x is equal to 120. And then if I divide both sides by 100, my x is equal to, slide the decimal point twice, 1 2/10. But 1 2/10 what? In this case, it turns out to be miles. So the plane is at an altitude or a height of 1 2/10 miles after it's already gone 3 miles horizontally at a 22-degree angle of elevation. So you can see it's pretty much like our previous problems, it's just now you have to build the picture. So we got one more, and you could try it on your own, although you'll need some serious patience with your numeracy because the long division at the end gets long. No pun intended. So be ready for that. Here we go. If you haven't tried it, get going. Hit pause. So from the top of a 100-foot lookout tower, a forest ranger spotted a fire at a 25-degree angle of depression. So I'm going to go ahead and annotate this, meaning going down for angle of depression. How far was the fire from the base of the lookout tower? So how far was the fire from the tower? And not just the tower, but the base of the tower. We need a picture. We need a tower first. Here's our tower. Here's the ground. Here's my fire. Zoom in a little bit so we can see the excellence. Get a little smoke going here, shall we? Oh, look at that. That's good stuff. Okay. So you're hanging out up here in the tower. You're the ranger. Now, normally you're just looking straight out like this. But all of a sudden you see the fire. So you're going to depress, or your view is going to go down. And now you're looking down at the fire. So this is 90 degrees, okay? And your view just depressed 25 degrees. Where did I get that? From over here, a 25-degree angle of depression, going down. So from where we're looking, we're going down 25 degrees. Now our tower is 100 feet tall, and what we want to know is how far was the fire from the base of the tower. So not just from the tower, because it could be from the top or the bottom. No, from the base of the tower. So my find is really this. This is how far the fire is from the base of the tower. The base means the bottom. So I don't even have any degrees in here. Now there's two ways you can get one of these angles. The first is to realize these are parallel lines, and if this is 90, so is this. So if this is 25, these two angles here have to add up to 90. So that would make this angle in here 65 degrees. Or you could realize that these are parallel, and these are alternate interior angles right here. So you can make this 25 degrees, because you know they're congruent when the lines are parallel. Either way will work. Just remember, angle of depression means going down, so you have to start up here, and the going down is out here. That was the angle, not this one. Most of you will make a mistake and make this the 25. Be careful. There's your angle of depression. So now let's go ahead and write an equation. To do that, we have to figure out which reference angle we're going to use, and the only data they gave us was with the 25-degree measurements, so we have to use 25. No choice this time. So here's our reference angle here. So if I'm going to use 25, let's see, this happens to be the adjacent, and this angle over here, sorry, this side over here happens to be the opposite. I'm not even using the hypotenuse, which means what I can do is go ahead and write out the equation for opposite and adjacent. And which one does that? SOHCAHTOA. That's going to be tangent for opposite and adjacent. So tangent of the 25 degrees is equal to the opposite of 100 over x, the adjacent. And if you look back over here at our table, it's 46 hundredths for tangent of 25. So I can put in 46 hundredths, and now it's just numeracy time. If I go ahead and try and cross multiply, now I might want to reduce this here. That might be a really good idea, divide both these by 2. let's say, and you get 23 over 50 and 100x, and there's no more reducing to do there, so I'm kind of stuck. I got to cross multiply. We've got 23x equals 100 times 50, that's 5,000. So when you divide both sides by 23, you have a little bit of work to do. If we finish this out, I'm just going to go ahead and look at my calculator. Normally you'll have to do this out though on scratch paper. We get 5,000 divided by 23, and it looks like it's 217 and 39 hundredths. The units are feet, but don't forget we want to usually round to the nearest tenth, so this is approximately equal to 217 and 4/10 feet. Be patient, particularly with the numeracy, and remember angle of elevation, you're going up, angle of depression, you're going down, and it's the angle out there. Good luck.